So a continuous graph is a graph that is unbroken. If you don't pick up your pencil as you're tracing through the dots, you are drawing a continuous graph. A discrete graph is, yeah, it is. It's secret. It's a graph that is composed of distinct isolated points. That means it's just a bunch of dots. Okay, just a bunch of dots on the graph. So it's discrete in the sense that you don't know what's happening in between the dots. It's the type of graph that it would make sense to connect the dots. Okay.
Yeah.
So we got that written down? So a continuous graph might look like this. See how I didn't pick up my pencil? And a discrete linear graph would look like this. I'm picking up my pencil as I draw dots. It is a little bit off.
It's okay, my drawings are off. Yeah.
So continuous, discrete. Both of those are linear. Solutions. The set of all solutions of an equation forms the equation's graph. So solutions are just all the y values corresponding to x values that land on that graph. Or land on that line.
Those are essentially like single data points.
Yep. So draw a continuous graph, draw a discrete one, and let's go ahead and go down to the table on the bottom. Oftentimes what we'll do is we'll use an XY table. You probably did this last year, where we give you the x coordinates. We're going to do this on your skill test coming up Thursday. Okay. We'll give you the x coordinates. You plug them into the function. They give you y coordinates, and then you plot them. Okay. And then maybe answer some questions about it based on the graph. All right. So here's the function. It's y equals negative 2x plus 1. This is a linear function. It's a linear function that's going to be going down as we go from left to right. So you'll see that happening. We're going to connect the dots to make it a continuous function. But before we do that, we need to understand, where do these dots come from? Okay. So what we're going to do on your skill test is we'll give you the x values. Okay. So you see this first column here? We'll tell you what to plug in most of the time. Sometimes we might have you come up with numbers. If we ask you to come up with numbers, we're just asking you to maybe try one negative number, 0, and then 1 or 2 positive numbers. Is usually enough. You actually need 2 points to graph a line, but it's a good idea to have maybe a couple extra points to try. So if I plug in negative 1 right here, use my calculator or do careful arithmetic here. Negative 2 times negative 1 is 2. 2 plus 1 is 3, and you'll see that's the value I have for y right there. So it gives me a coordinate. Negative 1 is the x coordinate, and 3 is the y coordinate. What happens if I plug in a 0 here? What do you get when you plug in 0?
0?
Yep, this is 0, and then I have to add 1 to it.
1.
So it's 1. Okay. What happens if I plug in 1 here? Yep, which is negative 2. Negative 2 plus 1 is negative 1. What do you notice is happening? Do you see a pattern? 3, 1, negative 1? Yes. Negative 3. Good. Because this is a linear function, there should be some kind of pattern there. A common difference in the y coordinate. So now,
That's crazy.
okay, so first part on the skill test, you'll be asked to do this. We won't have all the work here. You'll be doing that in the blank space at the bottom or in your head. Okay, so I'll give you the x values. You'll find the y values. Then you're going to plot the points. So negative 1, 3 would be 1 to the left and 3 up. And 0, 1 would be none over, and 1 up.
You know what this is? It's already discrete.
It is. The way I'm drawing it right now, it's discrete. We're going to connect the dots so and make it continuous. Then the next one is 1 over negative 1 down. And then 2 over and 1, 2, 3 down. It is linear. We already knew that because we saw the pattern right here. You know, it was a difference of 2 for each one. So it's discrete right now, but we're going to draw a line through it. Well, once I draw the line through it, now it's continuous. But until I did that, it was discrete. You don't need to write anything. We're just going to draw a continuous function and leave it at that. Okay. So the only other thing we're going to do on this is your next skill test. We're going to ask you certain things about it, like when you're at a value of negative 1, what is the output? What is the y value? You have to read it off the graph. Or when you're at a value of about 5, what is the input? What's the x value that goes with 5? So kind of reading off the graph here. I'm going to do an example of that later. But like if I'm at over 2, it looks like I'm down at negative 3. If I were to continue the line down to the right, we could, given a certain x value, predict the y value. That's it. Read off of the graph. So does everybody have this written down? Your line there? Let's go to the next page. All right, graphing a real-world functions rule. This is when we did these skill tests, we made an attempt to do some real-world sorts of functions. So it might look a little more like this. It says the function rule W equals 146C plus 30,000.
You want to read it?
No, just follow along and not be talking. Represents the total weight in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? So the function rule is W equals, or W is the weight in pounds. So down here we have W, which is weight. And the unit is LBS, which is pounds. So write, oh, I did it backwards, sorry. Take this out, great. Watch this though. Watch this magic. So it's W goes right here. So just click on yours, rotate it, and then move it over there.
Click on it?
Yeah, rotate it, move it over. You can't do that?
Yeah.
Sorry guys.
Buy me the new smart paper.
The new smart paper.
The
Yeah.
one that doesn't have a pencil.
When you're a sponsored mathematician like myself, you get these kind of perks.
Wait, you're sponsored?
Oh
So you
yeah,
mean the teachers that don't have
Is
smart
someone
boards?
sponsoring you?
Apple.
but it's not sponsored. Yeah. So if you wait till we're done with the notes. Okay, and then down here we have a C, which is the cubic feet of concrete. So this is C cubic feet. So do you guys see why I had to switch it? W is actually in the place of Y, and C is in the place of what has been X on most of the ones we've done, right? So that's why. So we're going to have some coordinates here. I only have a table with 3 points in it. Does it make sense to plug in negative values here for C? Could we have negative cubic feet?
Yeah.
We could? What would that look like? So, yeah, we could have 0 cubic feet, I guess. We could start there if you want. So if we had 0 cubic feet, that would just be the weight of what? Well, air and what else?
Hey,
What's the cubic feet of concrete in?
We could do negative cubic feet.
Why?
Or
What?
you just click on the smart board and flip it around.
Flip it around. Okay, if I plug in 0 here, what am I actually calculating? The weight of what? And it's not nothing. There's still 30,000 pounds there. What does the 30,000 pounds represent? Weight of what? Nothing. Air doesn't weigh that much. Okay, what am I hauling the concrete in that weighs 30,000? Yes. Okay. So the first coordinate is 0, comma 30,000. Then I could plug in. Let's plug in a couple more here. Maybe plug in This is about, let's see, if the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? So, guys, if the capacity of the truck is 200 cubic feet, and I only have room on my table for maybe 2 more values, that's what I was thinking. Let's plug in 100 here, and then 200 here. So it'll be W equals 146. The 100 and 200, I just came up with them based on the fact that the capacity of the truck, that means as much as it can hold is 200. And I know that I only have 3 values, so I'm going with 0, 100, and 200. I just split that up into three different numbers. All right, so Nolan, did you get this? Nolan? 100, 200. So we're going to plug in 100 on the next one, plus 30,000. And then on the next one, it's W equals 146 times 200 plus 30,000. I might need some help on these, guys. I need some calculation help. Well, maybe. Actually, I don't. You can do it. I do. So I'd like you to punch it in for me. So this is 100, comma 14,600. Add that to 30,000. So it's 44,600. Might be confusing that maybe we should take out the comma and the one above it, huh? Oh, there it is. 0, comma 30,000. I forgot I had these on here. 100, comma 44,600. Okay. Don't get confused with these commas, guys. That is confusing. So it's 100, comma 44,600. So it's just really, there's the comma that separates the x and the y. And then the last one, if I plug it in, I guess I don't need help. Do the calculations.
Hey, why were you writing what you turned down?
Why was I writing? Because I forgot that was on there. So 200, comma 59,200. So my little red thing is the actual comma that separates the two numbers. Okay? Maybe make one comma bigger and the other one smaller. So now I have these 3 points, 0, comma 30,000, 100, comma 44,600, and 200, comma 59,200. Do you have any ideas on how I should scale the bottom part?
You scale it and then we copy it.
Okay. Do you have any ideas on how I should scale it? We can do that. What I want to do is go from 0 to 200. So what would be a good way maybe to split up the bottom?
Well, you go to 30,000 and you skip a
I could go by hundreds, but then I'd only use 1, 2, 3 of these lines. 50 might be better. I think I would probably go with 50. It looks like I went by 25s. But somehow you got to break this up so it's kind of spreading the data out. And so it looks like I went by 25s here. What do you think on the y? How should I scale the y, do you think? Any ideas? 50? Well, but it's got to go all the way up to 59,200. Let's see what happens here. I went up by, starting at 10,000, went up by 10,000. Okay? You should, yeah, it looks like it covered it up, huh? You're going to have to write these on your graph, guys. It looks like it covered up. I should have pulled those aside. So please scale. So Austin, here's the I do it, you copy part. It goes 25s on the bottom, and it goes up by 10,000s along the side there. So please do that. Are you copying this down?
No.
Okay, copy down the scale. On your skill test,
you
you...
move the things though.
I goofed on that. I didn't put them in one.
Yes, you did.
Yeah, you could.
Actually, can we just like
Maybe do that. Josh,
graph it and go off the we still have the lines.
you do still have the lines.
That's what I'm saying. Can we just like graph it and go off?
Probably could.
Yeah, I'm just gonna do that.
So the first coordinate is at 0, comma 30,000.
Your Windows performance is slow.
I know. And then the next one is at 100, comma 44,600. That's pretty close to 45,000, so maybe right about here. And then the next one is 200, comma, 59,200, so just under 60,000. Would it make sense to connect the dots on this?
Yes, it would.
Could you have cubic feet that you're putting in the mixer truck between 0 and 100? Yeah. So it makes sense to connect it. So if I told you guys to estimate what is the weight of the truck, okay, listen carefully here. What is the weight of the truck if I have 150 cubic feet of concrete? Can you estimate off of your graph?
A lot.
It is a lot. Go ahead and graph it. So I'm going to go over to 150. I'd like you to do this on your graph because I don't know if you'll be able to see it on mine. Draw a little vertical line up to here and a little vertical line over to the side. Where does that land when I go? About 50,000 pounds. So if I have 150 cubic feet of material or concrete, it's about 50,000 or 25 tons. Yeah, that's how they measure it. Which means certain places you may not be able to go with that picture. You know what the rating is on like the mosquito bridge to say how many tons? 3 tons of weight. 3 or 5, so not very much. Okay. You're not driving the concrete truck over the mosquito bridge. You probably get stuck in between anyways. It's probably too wide.
You too, Chris.
All right. So finish copying that down, and then we'll move on to the next one. I don't see anybody else still copying it. You guys have it? All right. Here we go. Identifying continuous and discrete graphs. So, almost did what again? Yes, I almost did. It's close. So, yes. Yeah, I'll wait till it's quiet.
Oh, I thought you said birds don't breathe.
Okay, a local cheesemaker is making cheddar cheese to sell at a farmer's market. What? Okay, 1 gallon of milk makes 16 ounces of cheese, and he sells a wheel of cheese for $9. Write a function for each situation. Graph each function. Is it continuous or discrete? So, a local cheesemaker is making cheddar cheese to sell at a farmer's market. 1 gallon of milk makes 16 ounces of cheese, and he sells a wheel of cheese for $9. Okay, so these are 2 separate graphs. One of them, if I write an equation for this one over here, it's y equals 1 gallon of milk makes 16 ounces of cheese. So if y represents gallons, let's see here. Actually, let's let x represent gallons. So if I write down this equation, y equals 16 times x, go ahead and write that down. So y will represent ounces of cheese. Just draw an arrow and label it ounces of cheese. And x will be gallons of milk I need. It's cheddar cheese. Cheddar cheese, of course. So we have y equals 16x. So if I label, you have a table in there, right? It's kind of hanging over here. Okay, label this x and y. X and y. So what values of x should I plug in? You might be able to look down here and kind of get an idea. Maybe start with 0, go to 1.
Yeah.
2, 3, 4, 5. Maybe that's good enough.
What about negatives?
No, we probably don't want to do negatives. Why not?
Oh.
Yeah, that'd be like negative gallons of milk. I don't know how to even
Yeah, you can throw away the gallons of milk after you're done with them.
Okay.
Gallon of milk.
So if I plug in 0, I get 0. If I plug in 1, I get
16.
plug in 2, I get
32.
plug in 3.
48.
Look at that. Plug in 4,
4.
plug in 5.
80.
Wow. Fast. 80. Hey, look at that. It goes up to 80. So one of these graphs is going to be continuous and one is discrete. But let's go ahead and plot the points first. Here's 0, 0. Okay, guys, I'll wait till it's quiet again. Some of you, I think, are getting behind on this. Are we keeping up here? Okay, we've got the table filled out, the equation written down, right? Let's go ahead and graph these points. 116 is about right here. 232 is just above the 30 there, maybe about there. What can I use, what fact can I use to help me draw this graph? What kind of graph is this?
Cheese graph.
The cheese graph.
Cheese.
What kind of cheese? Linear cheese, right? Linear. Linear. So 348, 464, and 580. So could I feasibly put in any amount of gallons of milk and produce any amount of cheese?
If you're a cow, yeah.
I own the cow, so the cows could the cow give me 1.2 gallons of milk?
I don't know, you gotta ask. You gotta ask your guy.
So this makes sense.
Chickens don't make milk. If the cow can't do it, what is wrong with it? What kind of farm?
To connect the dots, this is continuous. I can make any amount of cheese I want. I could put in any amount of milk I want.
But what kind of animal is it?
Doesn't matter.
Yeah, there you go. Chuck Norris can help you.
Okay, let's do the other one. Label your table X and Y. And we got to write an equation. Y equals, this is for the price. So I can sell a wheel of cheese for $9. So if I call this 9X, then X represents wheels of cheese. You know what I mean by a wheel of cheese? And Y would be cost or profit or whatever. So this one, you know, I can sell, well, I'm going to tell you that I can only sell wheels of cheese. I can't sell half wheels. I can't sell quarter wheels. I can only sell a full wheel of cheese. We package it as a full wheel of cheese. Need pictures of a wheel. Sometimes you see them at Christmas. They come in with the sausage and stuff and crackers and little wheels of cheese. You know what I mean? So if I can sell a little wheel of cheese for $9, maybe a little wheel about this big.
$9.
$9.
Can you put it on a car?
0, 1, 2, 3, 4, 5. Plug in 0, that's $0. Plug in 1. Okay, enough. 1, it's $9. 2, it's 18. 3, it's 27. 4, it's 36. I'm just multiplying by 9. 5 is 45. So on this one, if I can only sell them as wheels of cheese, it does not make sense to connect the dots. You with me?
Yeah.
If I sell 0 wheels of cheese, I've made $0. If I sell 1, I've made $9. I cannot make in between 0 and $9. I either make none or I make 9. The next one is 2 is at 18. 3 is at 27. 4 is at 36. Well, if it's a sale, I got to do 2 for 1 because I can't cut them in half. It opens up the package, the cheese gets ruined.
You can eat it.
5 is 45. So do not connect the dots. This is what we call a discrete graph. This is a discrete graph. So finish copying that down.
Discrete.
Discrete graph. That is a discrete graph. Okay, so what we've done so far have all been linear functions. And we're going to move on to nonlinear functions next. I'm going to give you another minute to finish filling in that table and plotting those points and labeling that discrete.
Are we gonna go outside?
I think we're going to make it today. We're going through this fairly quickly. We don't have time, I think. As long as it's not pouring out there.
Can we do it in here?
You gotta go. We could do it in here. It's a little difficult to move around in here for it. We're going to do some human graphing. Okay, so actually, guys, when we go outside, most of the graphs, 80% of the graphs will be linear like these. One is going to be nonlinear like one of these that we're about to do next. So, this one may be a surprise for you guys. I don't know that you know what this one looks like. This one, yeah, both of these might be a surprise to you. Let's go ahead and fill in the table, okay? So we're going to pick some values. I do want to use one. Here, okay.
-1.
I want to use some negative numbers in this one, though. It's not
Negative
real
one.
life.
Oh, we can use -1, 0.
I'm actually going to use -2, -1, 0, 1, 2. Yep. Okay.
That's
And
too hard.
you know what? If I just give you a generic graph and it's not something that's only going to be positive, just go ahead and try a couple negatives, 0, and a couple positives. So if I happen to give you a table like this, it's blank, and you're not sure what the graph looks like, just try these numbers. Whoops, -1 and then -2. Oops, 1, 2. Oh, look at that. I forgot that was there too. There it is. So I was thinking the same thing before. So fill that in, -2 all the way through 2. And then we're going to plug in values here. You remember what this symbol means?
Time.
And what do we do with the absolute value of -2? What is it? Sometimes.
2.
It's 2. Absolute value of -2 is 2. So if I plug in -2 right here, 2 minus 4 is not quite. 2 minus 4 is -2, and that is my y coordinate right here.
-2, -2.
-2, you take the absolute value of it, it's +2. 2 minus 4 is
Oh.
-2.
Oh, I see.
Then the next one, if I plug in -1, what does this become?
1.
Yep, and 1 minus 4 is
3?
-3, yes.
3.
So that gives me the coordinate -1, -3. And then the next one, plug in 0. That's pretty easy to do, right?
Is it 0,
Absolute value of 0 is still 0. 0 minus 4 is -4.
You're going too fast.
I know.
1
I'll have the whole table filled out.
It's -3.
Do you understand what's going on in
No,
here?
I do not. Yes.
And that's a problem. So, Austin, here's what we're doing. When I plug in -1 into the absolute value symbol, what does the absolute value symbol change to the -1? Okay, that you need to know. So, absolute value means take the positive version of it, change it to positive. So, -1 becomes +1.
I got it. I was just
1 minus 4 is -3.
It looks like an arrow.
What does? Oh, yes, it does. We call it a V, though.
Oh.
It does kind of look like an arrow. You're right. It could look like an arrow. It could look like a check mark, depending on which points we end up plotting. So here we have y equals absolute value of 1, which is 1, minus 4 is -3. So you're going to see it starting to come back up like Nolan's talking about here. And then the last one here, when I plug in +2, absolute value of +2 is still 2. 2 minus 4 is -2. And so there's the next one. It's 2, -2. And so I have my coordinates. And now I need to graph. So let's go ahead and graph the first point. -2, -2 is 2 to the left, 2 down. This is the first point here. -2, -2 is what I'm graphing first. And then -1, -3 is down over here. And then 0, negative 4 is kind of the point of my arrow or of my V. And then we have the point 1 over negative 3 down. It's starting to come back up again. And then we have the point 2 over negative 2 down. It's like you have two lines coming together
Clock.
at a point. Could be, yeah, the hands of a clock. That's true.
Yeah.
Or an arrow, or a V, or a check mark. If I had only graphed part of that, it'd look like a check mark. So this is an example of a nonlinear function. One of the ones we're going to do outside will be nonlinear. So
Oh, we're doing it outside on the concrete?
we're going to do it on the football field.
Oh.
So I have
You get to
a
draw stuff?
No. I think so. We'll have time.
Guys,
All right.
let's put you to when we get out there.
No, that would bring us back inside if we do that.
Good, please.
All right. Let's do the next one, guys. So, let's finish this one up. Here we go. Next one, write it down. Okay, this is the one where, guys, in terms of what you got. Now, you got to be careful here. That's not quite right. Here's why. You see how I have parentheses around? So when I plug this in, what's negative 2 squared equal? Positive 4. Okay, it's important that you get positive 4 at that, otherwise you won't have the right graph. So it's positive 4 plus 1, which is 5, and you'll see that number right there. So, guys, you need to plug in these negatives in parentheses. If you do this in your calculator, which you may want to do.
Hold on. What are you doing?
Try and keep up. I plugged in negative 2 here first, and I put it in parentheses to tell me to take negative 2 times negative 2, which is positive 4. Then in the second line, I'm going to plug in negative 1 right here. Negative 1 squared is 1. 1 plus 1 is 2. Okay, so there's the second coordinate, negative 1, comma 2. So then, I'm going to plug in 0 for x. Put it in parentheses. 0 squared is 0 plus 1. And so my next coordinate is 0, comma 1. So it's kind of coming together here with the shape. Do you guys know what the shape of this will be already?
Yeah.
You do? How would you describe it?
Yeah, it's like it's got 2 round. Well, do I have one?
Okay, the next one is 1. We plug in 1. 1 squared is 1. 1 plus 1 is 2. So 1 comma 2 is the next one. And then the final one. The final one. Plug in 2 in parentheses.
Hold on.
Try to keep up.
Whoa. Try to keep up.
2 squared is 4.
Oh, he's too fast.
4 plus 1 is 5. Good. So I'll leave that there so you can copy down the table. You have 5 coordinates. Can you plot those? It is.
I haven't even done
We have a way to describe that. It has a name. It's called a parabola. And it looks like a U. It should look like a U as you graph it. Let's try it. So negative 2 comma 5. Then we have negative 1 comma 2. It's coming down towards the y-axis. 0 comma 1 is right here. Now, hopefully, guys, you see that this one is curved and not made of straight line segments like the one above. So 1 comma 2 is here, and 2 comma 5 is up here. It goes like this.
It's the same, it's just going down.
Wait, what's the last point?
The last point is 2 comma 5. So I'd like you to finish plotting those points. This is called a parabola. It's a U shape.
I like Freddie.